Fine-tuning and RAG solve different problems. Fine-tuning changes how a model behaves. RAG gives it fresh external knowledge when it answers. The key is knowing whether you need better behavior, better information, or the right balance of cost, control, and maintainability. So far, we've built the foundation: how context works in traditional ML and LLMs, how RAG retrieves external knowledge, and how fine-tuning changes model behavior. Now we're ready to compare RAG and fine-tuning directly. The key design question is where context should live. Fine-tuning bakes patterns into the model, which makes it useful for consistent behavior, style, or domain-specific reasoning. Retrieval keeps knowledge outside the model, which makes it better for changing facts, citable sources, or data you need to control. In practice, strong systems often combine both. Tune the behavior, retrieve the knowledge. A fine-tuned model learns changes into its weights, so updates look more like software releases. Collect examples, retrain, validate, and redeploy. That works well for stable behavior, policy style, or domain patterns. RAG treats knowledge as an external source. If a product catalog, support FAQ, legal rule, or internal document changes, you refresh the source or index. Choose fine-tuning for slow-changing patterns and RAG when freshness matters. When knowledge changes, the update path looks very different. Fine-tuning means adjusting training data, running training, evaluating behavior, and deploying a new model version. RAG is closer to a content refresh. Ingest documents, chunk them, embed them, update the index, and test retrieval. Fine-tuning is slower but can shape behavior. RAG is faster to refresh, but only if retrieval quality stays high. Start by diagnosing the gap. If the model needs facts it does not have, policies, product docs, customer records, or current information, use RAG to bring that knowledge into the answer. If the model already has the information but responds in the wrong format, tone, sequence, or reasoning pattern, fine-tuning may help. Don't fine-tune expecting perfect memorization, and don't expect RAG to fix bad behavior by itself. Cost is not just a question of which option is cheaper. Fine-tuning often concentrates cost up front, preparing examples, training, evaluating, and sometimes hosting a custom model. After that, requests may be simpler and shorter. RAG shifts more cost into the live system, ingesting documents, creating embeddings, maintaining a vector database, monitoring retrieval quality, and adding search time before generation. Actual cost depends heavily on scale, provider, and architecture. In production, RAG is much more than a single search call. Documents have to be parsed, split into useful chunks, embedded, stored, retrieved, ranked, and shaped into a prompt the model can use. A mistake early in that pipeline can echo all the way to the answer. Bad chunks hide evidence. Weak ranking fills the context with noise. Poor prompts waste good retrieval. And without monitoring, stale content and silent failures can go unnoticed. Fine-tuning shifts complexity from prompt assembly to lifecycle control. Once you train a model, you need to know exactly which dataset, configuration, and evaluation results produced it. Evaluation should confirm that the target behavior improved, while regression tests catch damage to other tasks. Deployment adds practical concerns too: custom endpoints, access controls, and monitoring. Because models can surprise you, every release needs versioning and a clear rollback path before it reaches users. Fine-tuning is like teaching one shared brain a new habit. That works well when every user should benefit from the same behavior, tone, or domain pattern. Personalization is different. My account balance, your project history, and another team's permissions should not be baked into model weights. RAG handles this by retrieving the right folder at request time, so the same model can respond differently and safely for each user or session. RAG gives you a clearer evidence trail because the answer can point back to retrieved documents, snippets, or IDs. That makes audits, compliance reviews, and source verification much easier. Fine-tuning gives control too, especially over tone, format, and repeated behavior. But the reasoning is embedded inside the model. For traceability, prefer RAG. For consistent behavior, use fine-tuning, backed by evaluations, constraints, and safety tests. Privacy risks show up differently in each approach. With RAG, private content can stay outside the model, but every retrieval must enforce permissions, tenant isolation, access filters, and audit logs. With fine-tuning, the critical boundary is the training set. Remove unnecessary sensitive data before training, because once a model learns something, deletion and proof of removal become much harder. In both cases, security has to be designed into the data path. Choose RAG or fine-tuning by testing, not guessing. For RAG, measure whether the right content is retrieved, whether answers are grounded in it, and whether the final response is correct. For fine-tuning, measure task performance, style consistency, and regressions on older examples. Then compare latency, freshness, cost, and user satisfaction. Human review matters, especially for tone and trust. A small prototype usually reveals the real bottleneck, missing knowledge or behavior. Often, fine-tuning and RAG are strongest together. Fine-tuning shapes behavior, tone, formatting, instruction following, and tool use. RAG supplies the knowledge that should not be baked into weights, current facts, citations, policies, and customer-specific context. In a hybrid system, retrieved evidence becomes part of the prompt, and the tuned model responds in the right style. The trade-off is more moving parts, so design, evaluation, monitoring, and failure handling all become more important. The key distinction is simple. Use RAG to bring in knowledge, especially fresh, external, cited, or user-specific information. Use fine-tuning to shape behavior, formatting, style, and domain task patterns. Always weigh latency, cost, privacy, evaluation, and maintenance. Next, we'll prepare fine-tuning data that teaches those behaviors clearly.